Okay, so can you hear me?
Yes.
Okay, good. So let me share my screen. Okay, so good evening, everyone, again. Welcome to our extra session of the NPTEL live session interaction of non-conventional energy resources course. The course is taken by Professor Prathap Haridoss from IIT Madras, and I have taken the live interaction session for all 12 weeks. And this is our extra session for any kind of doubts, queries, and any other questions you have. So one more thing is, for today's session, I have prepared a presentation which is slightly different from the previous week content. It is just a basic presentation for providing information about basic science or physics. So it is not like that if you are not looking at the presentation, you are missing out something, any course content from the course, but it is just an add-on to your knowledge. And if you like, you may just go through the presentation. Otherwise, the course syllabus is done, and we can have the interaction directly if you like. So what do you prefer? Should I present the extra presentation, or you directly want to go to the interaction session? If anybody can respond.
As per me, you can run through the presentation.
Okay, then okay. So basically, it is a presentation of 1 to 2, actually more than 2 hours. But I am just briefly explaining the things because the presentation is meant for the either the higher secondary school student or the graduation students. So let us start with the presentation. So it is a very basic presentation, but you may find it interesting and you may like it. Okay. So the name of the presentation I have given is the physics in action and revealing the secrets behind everyday's miracles from kitchen to atoms. We are just discussing about the physics behind every minute things or every small things you see in your daily life regularly, be it be your household, be it be your kitchens. So it is start from there, and we will go up to the structure of atoms. So we will touch a lot. We will cover a wide range. So first rule in the physics or any kind of science is you should be asking questions. Asking questions to your teachers, asking questions to yourself. Means your tendency to question everything should be there. Be it be physics or any kind of branch of science or engineering, your curiosity should be always there. If you want to cover some topic, you should at least cover 3 questions: what, why, and how. And ask yourself if you know these 3 questions for whatever statement or whatever uh, topic you are studying. So if you can cover this topic, your concept will be very clear. You don't need to memorize anything. So especially specifically in physics, so everything is logical. You don't need to remember anything. If you can, if you can understand the background and understand the logic behind the formulas or behind the principles or any other topics, so that will be clear to you. So the spectrum itself. So as I told you, you should question everything. So you may ask why this topic is in this particular color of different fonts or this different colors ranging from red to violet. So if I ask any student, so what is so special in this color or is this specific color pattern? Can anybody let me know what is specific in this, special in this pattern? So basically, this presentation is just for interaction. So that is why I'm just asking you to interact, and if you can tell anything.
It's a whip gear.
All colors are there.
Yes.
7.
7. So basically, it is representing the spectrum of your electromagnetic wave in the visible region. So that is why it is having the specific, or you also say the Vibgyor pattern or the rainbow colors. If I ask to a school student, they will ask it is in rainbow color. So is it complete? So if I ask, is it complete? So it is partially complete for the visible region, but if I need to complete it, I have to make it like this. So it is the visible region I have just traced out, but this visible region is very small in the whole spectrum of electromagnetic waves. So only from the 400 nanometers to 700 nanometers, we get the visible region where our eyes can detect the light or the radiation. Otherwise, all other regions are insensible to our eyes. So it starts from the gamma rays. So the wavelengths are very short. Basically, wavelengths are the uh, path traveled by a wave or for in one cycle. So here for gamma rays, the wavelength is quite small. It is around the size of nucleus, or you can say the size of atom or a nucleus. So it is 10⁻⁻12 meter. X-rays are around size of atom, 10⁻10 meters. Then ultraviolet of some molecules. Then it can go up to the radio waves, which are in the size of few kilometers. So these are the largest waves available. So usually whatever the FM radios and other radios we listen, these are based on the radio waves, whose wavelengths are quite high, so they can deliver the signal from a very wide range of distance. So then we start our discussion. This was just the topic of the presentation. Yeah. So again, as my introduction, I am Lalit Bharti, a Prime Minister Research Fellow in the Department of Physics at IIT Kharagpur. So you already know me. So I will bring you to our main slide. So what you see in this picture, so usually it is in mornings, but in evening I am saying you good morning. So what is special in this picture? So one can ask the question that why does the sky seems yellow or orange or yellowish or orangish in this picture? So what is so special and why we see different type of colors in sky during your daytime, right? During your morning, it is different. In afternoon, it's different. Then it's evening again. It shows a different nature or different color. So for that, we need to understand that how do we see a color. So this is the schematic or this is a picture. You can understand how do we see something. So let's say we have some object. So we incident some light on that because in dark we cannot see anything. We need light to see any object. So basically the object doesn't have any color. So we incident a white light. White light is made up of these 7 colors. Whatever light is absorbed by the object get trapped, and whatever the remaining one or the reflected one that only we can see. So either the reflect one or the counterpart of counterpart of your color, absorbed color, we will see the color of the object. So similar thing is here. The red color is reflected here. All others are absorbed, and only the green color is reflected here. All others are absorbed. So we see the colors of any objects just by reflection of particular colors or particular waves, uh, uh, or waves of particular wavelengths which are not absorbed by the object. So the similar kind of thing happens when we see sun at the from in the sky. So this is again the representation of how colors disperse. So you seen that when you go in this direction where wavelengths are lower, so your dispersion is higher. For red color, your dispersion is lowest, and for blue or violet, your dispersion is largest. So that is why you see sky mostly in the uh, blue color, because this is the color which is dispersed most by the interaction of particles available in the atmosphere of Earth. So sun rays are dispersed due to the particles present in the uh, atmosphere, and you see the sky color is blue. So blue light is scattered more effectively due to the shorter wavelength than the red. So what happens when you are usually see the sky as blue color, but in the morning or in the evening, the sun gets at the horizon. So the path covered by the sun rays gets longer. So this is if we are here at the earth, so path will be longer in this case of morning or evening. So the blue color light will be scattered more due to its short wavelength. So if it is scattered more, the remaining one is the red light. So we see the red light only, and that is why we see the color of reddish or orangish sky. So we have this opposite to blue, we have this orange color. So that is why we see the yellow or orange color as the color of morning sky. So this is the different colors of sky. Then we have done this topic. Then we came to our topic of our Earth. So we know that this is the Earth, and everybody knows that it rotates. By rotation of Earth, we get days and night. So if somebody asks this question, okay, how do you know the Earth is rotating? So your first answer will be that yes, if you can see the day and you can see the night, means your Earth is rotating. But what if I say you are in the dark room where there's no windows, no door, and you cannot see the outer sky, or you cannot see whether it is morning, it is evening, then how would you know that it's night or day, and or how the Earth is rotating? So there is a very famous experiment, and which is a very simple one also. So it starts with a very basic uh, experiment of class 11, and if you are from any science branch or any engineering branch, I'm sure that you have gone and you have done that experiment. So this is the experiment. It is called a focal pendulum. So this is just a swinging pendulum in two dimensions. So anybody have any idea how to get the idea of or the proof of rotation of Earth with this focal pendulum? So do you know any one of you know? Okay, so if not, let me just show you the okay. So this is the proof of concept. Like, how do you prove it? So you basically have a very large focal pendulum. So basically, it is heavy one. It is a heavy bob at the end, and you have a very long wire attached with it. So what will happen? It will just, when you start it, so it is heavy due to just avoid any kind of friction with air and any kind of uh, other forces which can stop the bob. So it is made quite high, quite heavy. So what will happen? You start it at some point and let it swing. So it will swing in a particular plane. So it is swinging, but what will happen at some point? Your Earth is rotating. So this is the arrow is showing the rotation of Earth, because this is north, east, west, south. So this is, let's say, the rotation of your Earth. This is the axis. So what will happen? Your pendulum is swinging in one direction, and at the same time, your Earth is rotating below. But you are at the Earth's surface, so you don't know. You cannot see the Earth moving, but you can see the change in the plane of pendulum. So Earth will move, and you will see if the pendulum is hitting this point, this object at some point, it will slowly move in this plane, and at some time it will hit this object also. So by the 24 hours of time, it will complete the 360 angle, and it will hit all the objects here. So it will give you the proof that yes, the Earth is rotating because the plane of pendulum is fixed. So Earth is rotating. That's why we can see the plane is changing. Plane of pendulum is changing of the oscillation. So I have a proof of audio, a video here. So you can also understand from that. First, let me start the video. Okay. So the pendulum started oscillations in its plane, and you can see there's some small beads or small balls are here, and it is till now it has not touched the balls, but okay, at this point it has touched the ball, and the ball dropped off at this point. So means the plane is shifting with some angle, and slowly your all balls will be, or the all objects will be in the will dropped off by this pendulum. So means in 24 hours, it is taking the whole rotation of 360 degrees. So this is just the presentation, or this is just the uh, how to prove that your Earth is rotating with with using just a pendulum. So that is why this model is looking simple, but it is quite important, and that is why it is kept in many international museums. So first one is from the Valencia, the Science Museum of Valencia in Spain, and the next one is from the focal pendulum installed at the new Parliament building of India in New Delhi. So this is also the same thing. The schematic representation, the outer the frame is moving, and your plane is changing. So that is why you see this kind of pattern. So green one is your trajectory of your planes. So we are back to our Earth. So we just there was a curiosity about why did life have become possible on Earth. So what is the most abundant or most important element of Earth? So anyone can say that yes, it is water. That water is most important in case of for the life being possible on Earth. So I have discussed few natural or few properties of water. Before that, we are looking at what is the state of water. So basically, the state of water is fluid. So let us see what is a fluid. So whatever flows is a fluid. or you can say material that flows or continuously deforms under a shear force, that is a fluid. So one misconception is the liquids are fluid, but no, all gases are also fluid. So fluid can be anything, but it's just flowing. So these examples are blood, honey, helium, air, and water. All these are fluids. Then fluids have some properties, and one of the important properties is the viscosity. Viscosity means the resistance of a fluid to flow. So if resistance is higher, the viscosity is higher, the resistance is higher, they will flow slowly. So like water have the low viscosity, but honey has quite higher viscosity. So honey flows very slowly in comparison with water. So these are again the same examples of water, oil, and honey. And what is the reason it makes the viscosity different? So basically the intermolecular interaction. So here we have some bonds in water. In olive oil, your bonds are stronger and the bond strength are stronger than water, but at some medium viscosity. Then in honey, your bonds are even stronger. So that is why you see the viscosity of honey is quite higher than the water. These are some examples. Then we have, okay, from our kitchen, we have this example. So basically, what will happen when we start pouring ketchup from the bottle? So if you have faced this issue, so when you have enough ketchup, then it will come easily. But if you have less ketchup and you try to get the ketchup out, so sometimes it sticks in the bottleneck and you cannot get it out. So what you do, you just tap on that or apply some pressure, apply some force, and it will come out. So basically, what is happening here? It has some viscosity slightly higher, and you are putting some pressure on it, so viscosity is changing and your ketchup is getting out easily. So this is an example of a non-Newtonian fluid. So let us categorize fluid. First is the Newtonian fluid, second one is non-Newtonian fluid. So Newtonian fluid is basically whose viscosities are quite similar in all conditions. All if any force is exerted or whatever conditions. So in presence of any force, any shear pressure, or its viscosity is not changing. But in case of non-Newtonian fluids, their viscosities are changing in presence of any force exerted on this, as similar to as we have seen on the ketchup for the ketchup. So these are the examples of some non-Newtonian, some Newtonian fluids. Then, so you can see the examples. So water is there, mercury, different oils, gasoline, petrol, diesels, mineral oils, honey, etc. So basically, their viscosity is not affected by the shear rate, or they do not change their viscosity. Then the non-Newtonian fluids. So non-Newtonian fluids is one of the most one very well-known example is the, you can call it oobleck. So basically, it's a solution of cornstarch with water. So what will happen? It is usually a liquid, but when you put a high pressure or high force on it, it behaves like a solid. So at the right side here, you can see it flows like a slightly viscous fluid. But when you just try to jump on it, you can even walk on it, or you can even dance on it, and it will be behaving like a rock or a solid surface. But when you start just standing on it, you will sink in this liquid. Similarly, if you are slowly touching some hammer or just putting some hammer on it, it will just sink down. Otherwise, if you just try to beat the fluid, so it will behave like a solid surface. So again, we have a video for that. But before that, we have some examples of non-Newtonian fluids. So basically, these are the examples from blood, glue, all the paints we used to color our houses, then whipped cream, gypsum paste, and all other things are example of non-neutral fluids in our daily life. So we have this video which will clear the difference of Newtonian and non-Newtonian fluids. So let us start. So this is your water. So basically its viscosity is similar. It's same for all the conditions, putting any kind of pressure, any kind of shear pressure, or any different shear rates. So the viscosities are quite same. Similar to honey, if you try to gently use a spoon or put any object, you can easily, it will easily go inside. And even if you try to put some pressure or some force and strongly hit the scale on the surface of the honey or with the hammer, so it will behave like a normal liquid. So this is the example of Newtonian fluid. And let us see the example of non-Newtonian fluid. So this is our non-Newtonian fluid. So basically, when you don't apply any force, so it is like a viscous slurry, and it behave like completely a liquid. But when you try to hit the or put any force, just like this, so it will behave like a solid surface. You cannot go inside it like a liquid. Similar to hammer, it will feel like a strong surface, like solid. And also some liquid will get out sticking to the hammer. But if you put it gently, it will just sink in the liquid. So it is one demonstration. So someone is pouring the starch solution in a bathtub or in a tub. And hammering it, it is like behaving like complete solid surface, even not splashing like a water. And you can even dance on this, you can even jump on this, but if you slowly stand up, you will just get sinked in this liquid, similar to a normal regular liquid. So here you are just putting pressure or just moving it continuously, so it is looking like a slurry, but as you slow it down, it will be a liquid. Similar case with the ketchup bottle we have already discussed. So this is the Newtonian and non-Newtonian fluid. Then we have a special class of fluid also, which is called superfluid, and this phenomena is called superfluidity. In this case, this fluidity is very high, or the viscosity is very low or zero. So they flow frictionlessly. Means even like if you have this kind of container, they will automatically come out of the wall like this. So from the wall, you can see the droplets are there. So the friction is so low and the viscosity is almost zero. So they automatically come out without any friction of the liquid. So this is example of liquid helium creeps up of the wall of container and dips down. So this is the special class which is called super. So we are back to our discussion on water. So we will be discussing the following points: how water boils. So maybe not cover the water boiling, and how why the droplet size looks like this. And so one thing is how you uh, water goes inside the tree to and reach up to the tips of the large trees. So what this phenomena called? So basically, we have seen this phenomena, and you have this kind of structure which is called xylem. Xylem is kind of a straw-like structure, and by using the surface tension and the capillary effect, the water is reached out to every part of the tree, from the roots to leaves and the flowers of the tree. So we will see how surface tension works. So here's another examples of the nature of water. So basically, you can see if you have putting some light on the surface of water, it will not sink, but it will just uh, be there on the surface of the water. Similarly, have you seen these kind of water spiders or some mosquito which can easily sit on the water, can walk on the water surface? Then the particular shape of water, when you put the so this curvature or the shape of the water will also discuss. So basically, this happens due to surface tension of water, and why the surface tension is generated. So usually you can see. So we have two types in a beaker. We have water. So we have two type of molecules of water. So molecules are same, but the surroundings are different. So here, when you have a water in bulk, so for each molecule, you have multiple molecules surrounding the center molecule. So if they are attracting each other, so all the forces are compensated by the atmosphere of a molecule. So similar thing happens with the another molecule. It will also see the surroundings molecules too. But what happens at the surface? At surface, let's say this is a center molecule, and in the water, inside the water, you have the molecules, but on the surface you don't have any molecule to just compensate the forces. So what will happen? We will get a net force downward exerted on this molecule. So by this, you will see you have some extra force remaining. So this will be the reason for the surface tension of water. Surface tension of water surface. So now we have got the why we see the spider can move, because they are using the surface tension and their legs are coated with the specific hydrophobic layers, hydrophobic material, so they can easily travel on the and sit and travel on the surface of water. So we see this capillary effect due to this surface tension of water, and you see so you see the capillary effect. Height of the water get uh, in the capillary higher than the actual surface of the water. So this is the reason, and this is the concept behind the how we get the water in the at the tip of tree from the roots. So this is done. Then we have a lot of discussion on water and the on earth. So let us change the dimension. So we know this is the structure of atom. So we have proton, neutron, electron. We already know that. So the question is, can't we go deeper inside the atom? So we have this particular dimensions of 10 to minus 10 for atom, and for nucleus we have 10 to power minus 15 meter dimensions. So the question is again the same, why can't we go deeper inside the nucleus? Can we go or not? So the answer is why not? Obviously we can. So we already know the structure of nucleus. So the atom is of 10 to minus 8 centimeter, then nucleus is 10 to minus 12 centimeter. Then we have gone to the proton or neutron. This is size of minus 13 centimeter or minus 15 meters. Then we have gone to the size of the quark, 10 to minus 16 centimeter or minus 18 meters. So we know that proton is not a particle, although the electron is a particle, but proton is not a particle. It is made up of this uh, this quark particles. So, but how do we know this structure? So it should be, it seems like it should be a very uh, tough question or very tough process to get to know what is structure of a proton. So, but it is simpler than you think. So let us assume this billiard ball is your atom or the nucleus, and it is looking solid from the outside, but from inside it have multiple particles the quark particles. So we cannot see inside it. So this is the made of glass here, but let's say we cannot see this. So what we have to do to know what is inside? So basically you need to break it. So simply how to break something? You collide some other particle or some other balls on this. So what will happen? With the collision of other ball, the ball will break. So similar thing. So it seems like a science fiction movie scene, but it is a simple. It is not a simple, but it is a simpler process to understand. So how to break a ball? Let us try to break a ball. So you put a target. Let's say here it is target, and you give high velocity to another object, and just throw the object to the particular ball. So what will happen? You are giving very high velocities, very high forces. So your another object will break down. So similar thing happens with the nucleus. So in case of nucleus, you have the accelerators. So these accelerators are very large in size. So what is there? So they are electromagnets, and let's say the target is nucleus. So you are taking a proton as the beam. So proton is a charged particle. So you can just circulate in with using some charged electromagnetic fields, electric fields and magnetic fields. So what will happen? They will rotate in this circular orbital with very high velocities. And whenever your velocities are very high, so you can just directly hit or give the collision to your target nucleus. So it will break down and you will get, so it will come here. So your target is here. So it will break down and then many detectors are present. So you will get to know what is inside the structure of nucleus. So this is a typical map of uh, accelerator. So these are very huge in size. So you can see the diameter is around the size is 27 kilometer, or the length is 27 kilometers. So it is from the Switzerland. So it is situated in many countries from France to Italy to Switzerland. So it is called the LHC is there, and the LHC means the Large Hadron Collider from the Geneva. So you can also see the map of here. So the size is very huge, and you can understand you can imagine what will be the size of the accelerators. And inside the accelerator, you can just imagine here's the person is standing, and this is size of an accelerator from the inside. So this is basically cross section, and the beam is very narrow. It is let's say if it is a proton beam, the size is close to about minus 15 meters. So for a very narrow beam, you have such huge structures. You can see the structures, very large size of electromagnets here. Large size electromagnets here. So you can see how the particles are, how do we get the structure inside the nucleus. Then we have just few topics on magnetic levitation. So what is a magnetic levitation? Basically, these are your superconductors. So superconductors are having properties of magnetic levitation. So if you just cold it down to get a particular temperature and put in presence of some magnets, so what will happen? They will resist the magnetic field inside the inside the superconductor. So in this case, they will resist and they will provide a back force. So they will start levitating. So this levitation will give you a very smooth surface of air between these two solid surface, and will be having zero friction. So this is used in the technology. This technology is used in the maglev from Japan. Maglev means the magnetic levitation train. So they are also using the same superconducting magnets instead of wheels, because in wheels a lot of friction is there, so the speed is limited. So they are always standing without friction, and then you have different poles of N and S. Their poles are basically switching, so they are providing the displacement to the train. So basically, if you are continuously changing, you will first attract, then repel, and ultimately you will be having very high speeds of the train. So the train is able to achieve the speed of 603 kilometers per hour. So this is another example of the physics in your daily life. So basically, this is the example of Bernoulli's principle. Bernoulli's principle says whenever you have a high velocity of air, so your pressure goes down. So it is similar to, if you remember, if you try to spray anything from a pressurized spray can. So whatever material is there, or whatever gas is there, when it comes out, it feels cold. So similar happens to your perfumes or your deodorants bottle. So it feels cold. So basically, it is based on the Bernoulli's principle. Means whenever you are having a very high pressure of air or uh, high velocity of air, so the pressure will be low at that point. So similar thing is used for aircrafts to, or the airplanes to fly in the sky. So the aerodynamic structure is something like this. Whenever they're running on the runway, the velocities of airflow is higher at the upper side and lower at the lower side. So from the higher velocity, you will get a low pressure here, and for the low velocity, you will get a high pressure here. So what will happen ultimately? Your low pressure will give you a drift to the plane upward. So as much low pressure you have upside, your plane will get into the sky. So you'll get a lift due to the pressure difference, the lower pressure at the upper side and high pressure at the lower side. So this this lift will give you the flying of aircraft. So this is simply based on the simple Bernoulli principle. Similar principle is used in the air conditioners. So how your air conditioner is cooling your rooms. So basically you have a evaporator here and you have a condenser here. So evaporator is the unit inside your room and condenser is the unit outside the room. So what will happen? So there is a compressor. So basically it will compress the air or whatever fluid you have. And at this point, the fluid will expand very rapidly. So while expanding, as we know, when the air or when the fluids goes at very high velocities, it will cool down. So it will be very cold at this point at the evaporator. Then it will be cold, and by the using fans, your AC will give you cold air. Then back to the cycle, your uh, your expanded air will go in a compressor and it will compress it down. Basic compressor is a piston, so it will compress it down. And during the compression, we know the reverse process will happen and it will heat up this area. So the condenser will get heated, and that's why you have a exterior in the exterior unit. You have a outdoor fan to just remove this heat from the outdoor unit. So this is the thermodynamic process of the air conditioning to work. Then we have the magnetic flux, and this is the coils of transformers. So how the step up and step down transformers work. So basically, you have different coils here. So I'm just not explaining the whole mechanism. So the number of coils are different, and depending on the number of coils, you will get a magnetic field here. Your magnetic field will get transferred to the another coils, and if your number is different, your voltages will be different in the secondary coils. So if the coils are equal, or the coils are, if the winding coils are equal, then you will get the same voltage. And if your winding coils are lower in the secondary coil, so the voltage will be higher. And similarly, voltage will be lower in opposite case. So basically, you will get a step up or step down uh, transformer in this way. So thank you for this. So this was just a general discussion on the daily life of science of daily life. So I hope you like this. And this is done for today. So time is around 8. So you still have time for interaction. So if you have any kind of queries related to the course or anything related to our topics, so you are free to ask. Otherwise, you are free to leave. You may leave, and I will be here till 9 for today.
Hello. Hello. Am I audible?
Yes, audible. Hello.
Hello.
You are audible.
Yeah, I would like to ask the question to Mr. Lalit. Any model question paper for attending the examinations, or we have to?
Sir, any previous questions which are coming, which already came in the previous examinations?
Yeah, if that kind of questions comes, so at least we'll have an idea of how the questions to be prepared accordingly. You can
Yes.
prepare it.
That's a good question. Any question bank is available or not? That I would like to know. Sir,
Is on mute. Mute.
so please type the question. That will be better. You please type the matter. Let us wait. Hi, Mr. Suresh.
Yeah.
Where are you from?
I am basically currently I'm working in Mumbai.
Yeah, I am Ditish from Kerala.
Hi.
Hi. How is the preparation for the exams?
Just like that. Nothing. Altogether, I'm in different. Okay.
Okay. And the same problems we have done already from this course. And discuss the question actions will be similar to those assignments. Yeah, Suresh, Mrs. Suresh, all the best.
Yeah, thank you. This is same to you. Putting the wishes to you.
Thank you, thank you.
Yeah.
Sir, thank you so much for your class and all. Shall I leave?
Yeah, thanks to everybody. I need to drop off. Thanks a lot.